Hello everyone, welcome to IEEE SIESGST podcast. Where we bring you insightful conversations on emerging technologies, research, and career paths that shape the future of engineering. I am Sahil Chavan, and today's episode explores a domain that helps us understand our planet in ways far beyond what the human eye can see. We are honored to have with us Dr. Sangita Chaudhari, Professor and Head of Computer Science and Engineering Department at Ramrao Adik Institute of Technology, D.Y. Patil University, Nehru. With over 2.5 decades of experience, she is a GIS and remote sensing researcher and an information security enthusiast, known for her visionary academic leadership and learning-centric approach to education. Ma'am, welcome to our podcast. It's a pleasure to have you with us. Today's topic is Beyond the Visible, the next generation of Earth's observation. To begin, it will be wonderful to understand your journey and how your interest in GIS and remote sensing evolved over the years. So, could you talk us could you take us through your academic and professional journey and tell us what drove you towards GIS, remote sensing, and Earth observation research?
Yeah. Thank you so much for inviting me to have an interaction on this app topic. And first and foremost, I would like to thank IEEE student chapter branches and SIESGST for giving me this opportunity. Yes, so now coming to your question, it almost started 20 years back, and I can very happily share with you that in 2006 I was attending one of the STTP at SIES only, and that was a 2 weeks STTP in image sensing. And that time and that is how I came across the fascinating world of image processing, and I attended lot many sessions which were delivered by IIT Bombay professors. And gradually I started working on image processing. I started exploring a lot many avenues in image processing. And after my masters, then possibly I was thinking about my doctorate. So fortunately, as I was conversant with all the professors of IIT Bombay who were working on GIS and remote sensing, and it is the extended field of image processing. So that is one of the point wherein I thought now I can shift from image processing to remote sensing, and whatever knowledge I have, I can use that knowledge and I can do some research in GIS and remote sensing. So
Your
that
journey,
was my first interaction, or that was my first step towards GIS and remote sensing.
your journey clearly reflects how sustainable curiosity and leadership goes hand in hand with academy. Building on foundation, let's explore what Earth's observation really means in today's technological landscape. For students who are new to this field, could you explain what Earth's observation is and why it is so important today?
Yeah. So coming to Earth observation, actually, we know that all the times we are trying to capture some of the other view, but that is in visible range. And we are using so many cameras nowadays which are trying to capture the visible ranges. Okay, but the limitations are we have the sensors capabilities, we have the sensors limitations. But when it comes to Earth observation, we cannot do that in the visible range itself. So we need some kind of sensors through which we can actually get the complete insights about the Earth. Okay, and we need to use satellite for those things. So Earth observation for me, it is observing the Earth from the airborne satellites, so that we can get the complete view of Earth. And it is not only the visual observation. Okay, what is going beyond the visual, that is also playing a important role. So nowadays, if you see, Earth observation is not limited to just sense the images through satellite and then making it putting it in the database and make it available for the users. So if you see now, every now and then we are using the technology called as Google Map or Google Earth, and that is heavily relying on the Earth observation. And also, like for students to understand the earth observation is to find out each and every activity which is happening in the atmosphere at the natural this thing or the surface of the earth. So that is the basic understanding about the earth observation. And possibly we cannot just say it is the capturing. Continuous monitoring is also very very crucial, and it is helping us in lot many applications like disaster management, then the environmental monitoring, etc.
This explanation really helps students visualize how vast and impactful this field is. As technology advances, Earth's observation is also moving beyond what is visible, leading us to the next generation of observation system. The title of our podcast is Beyond the Visible. Could you tell us how moderate Earth observation system go beyond visual imagery?
Yeah. So now I will put more emphasis on how Earth observation evolved, and now why we can say that it is going beyond visible. So if we see in the Earth observation, people started using sensors. So if you go back to maybe 50 years back, okay, that time we have seen that there were very limited satellites which were owned by some topmost countries, and getting the satellite data is very very expensive. But now if you see, due to the tremendous growth in technology, electronics, and other communication media, there are so many satellites. Also, getting the images, or normally we know that satellites are moving and they're trying to capture the images of Earth's surface. So earlier we have a swath of satellite, okay, maybe once in a 6 month. So one image captured, okay, the same instance can be captured after 6 months. But now it is reduced drastically, okay, and possibly you can say that this swath is so frequent now, so you can capture the same field, okay, or same instance of the spatial data multiple times in a day, okay, or in a particular week time. So that is giving you a complete insight about the Earth observation. Now coming to the beyond visible. So before that, it is very much essential to understand what are the ways by which the sensing was happening. So possibly we all know the electromagnetic spectrum, and we have some frequency bands in that, and every band we can capture the some or the other characteristics, okay, based on what kind of reflectance and emittance we have from the object. So we as a human being, we are limited to the visible range, and we are capturing using those, okay. But when it comes to the Earth observation, okay, so we are going beyond visible range. So we are going to airborne satellite imagery or spaceborne satellite imagery, where we are concentrating on multispectral and hyperspectral images, okay, wherein instead of having, so in visual we are having only three bands, red, green, and blue. Now we are extending it to hundreds of bands in multispectral and thousands of bands, okay, in hyperspectral. So it is giving us the better spectral properties of the objects which are lying on the Earth's surface. Okay, so for example, I want to do the sugar cane quality assessment. So I don't need to go to the field and test the sugar cane and see the quality of the yield or the quality of the soil. I can use the satellite imagery, okay, based on which spectrum we want to work, frequency spectrum, and only we need to process that satellite imagery. Okay, so this is about the visible. Now, if you want to go beyond visible, so we have two very important and promising kind of sensors arrangement, and those are called as microwave remote sensing and thermal remote sensing. Okay, so in microwave remote sensing normally, and see, when we are trying to capture the visual images, if some obstruction come in between, or some occlusion comes in between, so we will not able to capture the image. So say satellite is far away from the Earth's surface. So if clouds come in between, okay, or due to some atmospheric interference, okay, or maybe because of rain, we could not capture the complete surface of the Earth. Okay, and that is one of the problem to process those satellite images. Remote sensing, which is called as synthetic aperture
Yes.
radar, SAR imaging, okay, which is going beyond that. And even if you are having the occlusions like clouds or rains, or even in the night time, that can be captured. And of course the second one, that is thermal.
Thermal.
Okay, so using thermal, okay, you can get the complete thermal pattern. Okay, you can also see what is going on inside. You can see the heat map island. Okay, you can see the deformations which are happening in the earth's surface, etc., using the thermal imagery. So if you see in today's era, not only the multispectral and hyperspectral, but SAR images, that is microwave remote sensing, and thermal remote sensing is playing very important role in Earth observation.
These achievements really shows how Earth observation is becoming more intelligent and predictive. Such powerful technologies are already making a real-world impact across multiple domains. So could you share some real-world applications where next-generation Earth observation is making a significant difference?
Yeah. So here I just wanted to emphasize on two or three major application. Of course, there are many applications. So if you take an example of smart city, okay. So when we say smart city, we want everything at the fingertip. And to make everything at the fingertip in the background, we need to do lot much of research. So the planning of the city, the infrastructure, the availability of the resources. Okay, so there are n number of resources. We can say electricity, then water, okay, the other kind of road network, drainage network. So all those things are playing very important role. And of course the Earth observation is having lion's share in that. So if you take, suppose I want to plan a smart city. So first of all, I need to find out the place wherein I can plan that city. So that site suitability analysis it itself is a big application, and it requires huge data which is coming up from the satellite. And also we should not forget the integration of this remote sensing technology with geographical information system, because whatever data is coming from the satellite, that is in a raw format. Okay, so the processing of that data, the integration of that data, then putting it in a proper format, and making it suitable for doing the analysis as well as visualization of that particular data is being handled by geographical information system. So these two technologies are going hand in hand, and possibly all such kind of applications can be easily executed with the help of this. So as I was mentioning in smart city, so we want all vehicles to be routed properly. Okay, the optimal route should be given. Okay, and if something happens at one place, okay, there should be possible ways to reach out to the destination through other ways. So all those things now we are using every now and then very seamlessly. Okay, but if you see inside the technology, so basically the satellite imagery which is coming from the Earth observations and the GIS, they're playing very important role. Coming to one of the important application, which is disaster monitoring and control or recovery. So if you see now, we have many natural calamities. We have earthquakes, we have flood, we have droughts. Okay, so if we get early signs of those, so if you see nowadays, okay, the government agencies who are working on them, okay, they were not getting any clue if you go 20 or 25 years back. But now before that thing happened, we get a intimation of those things, and we are ready for the getting rid of those kind of thing. So obviously here for the disaster management, okay, the satellite imagery is playing very important role, and not only the visible, but as I said, microwave remote sensing and thermal remote sensing. So they're playing a very important role, as you can time to time you can observe the earth's surface, and you can see the minute changes which are happening on the earth's surface. And that is how these things are giving you the prediction. Okay, instead of analysis, now we are focusing on prediction. So earlier if you see, as we were using only satellite imagery and few instances of GIS, okay, we could just only do the analysis, and that too descriptive analysis.
Yes.
But now in today's era, with lot much of integration of technology, like we are having machine learning, deep learning, then we are having big data analytics, cloud computing. So all those things are integrated together, and instead of having only descriptive analysis, now we could have a prediction, or we could get a recovery plan also, how to recover from this kind of natural calamities, how to evacuate people, and how to deal with all the worst situations which are happening. So beforehand only we are knowing all these things. And if you see now in many countries, many developed countries like US or Europe, okay, such kind of systems are already built. Yes. And before something happens, okay, they are ready to face that challenge, and before any flood comes, the whole community has shifted to a safer place, and that is how they are safeguarding the manpower as well as the important or the useful resources. Yeah.
This really highlights how technology and social impacts come together in this field. Working on such impactful technologies also requires strong research, culture, and leadership. As a professor and head of department, how do you encourage research, innovation, and interdisciplinary thinking among student and faculty?
Yeah. So the first thing which I would like to highlight is to develop such kind of ecosystem, you should first start from yourself. So if you are having those kind of qualities, and if you are providing a strong mentorship, okay, to the student, possibly they will understand what is the importance of, because see, this remote sensing GIS, this is an interdisciplinary field, okay, or any kind of research if you take. Nowadays everything is interdisciplinary. Yes. So students should know what kind of things are happening, how they are impacting the society. And one of the very crucial point which has to be noted is, whatever research you are doing, or whatever research you are carrying out, that should have some societal impact, okay, that should have some usefulness. So if you are building a prototype, okay, and later on it is not useful, yes, so there is no use of that prototype. So as a head of department, I make sure that all the students who are working on the research, okay, or they're doing some kind of mini projects, or maybe some collaborative research, they're participating in some hackathon or project competition, so they should take such a project which is having a societal importance, and later on it should be deployed. Okay, they should not do and just dump the things. Yes. Okay, they should see the real application, how to deploy it. And there are so many challenges, believe me. Building a prototype is very easy, but deploying that prototype for the actual usage is a challenging task. Yes. So possibly we are very keen to see that all the projects which are developed, okay, that should get deployed, and it should be useful for the society. Even if it is not useful to the broader community, at least to some community, if it is useful, the objective of the development of that particular thing is fulfilled. So those things need to be considered.
Understanding Earth observation, what role does computer science play in making sense of this data?
Yeah. So here I would like to mention a few myths. So most of the people think that GIS and remote sensing is the field which is related to electronics, okay, or which is related to the branches like environmental science and all. So, but here, if you put the emphasis and if you see how it functions, okay, so basically at the core, okay, if I take an example of the satellite images, so we know that satellite images are captured. The satellite is capturing the images. Those gets processed on board, and then they are being sent to the stations where they are stored. Now the next phase is very important. So those satellite images, okay, we cannot directly use those images, because sometimes those images are raw images. Okay, and if we want to make it useful for the human being or for some application, then possibly we need to process it. In the processing, we there are so many things, like once I have captured the satellite images, I need to see how it is getting, what kind of projection is being used, and I need to map it to the geographical locations. So that is called as registration process. So we are doing the registration, we are doing the projections, and then possibly here GIS comes in picture, and we are using GIS to process those images, and finally you are getting a product called as map. So everybody is using
Yes.
digital maps. So here now, if I take the example, so the computer science is playing very important role over here. Okay, because as I mentioned, the data has to be stored in the storage. It may be at the server, it may be in the cloud where we are having the server. So right from how it is getting stored, how it is getting retrieved, how it is getting manipulated, okay, at the same time how it is getting visualized. Okay, so here the basic understanding of data structure is very, very essential. Okay, also when we are putting that on the storage and retrieving and visualizing, there are so many data analytics tools which are being used, and those tools are playing a crucial role when we are visualizing that data. So if the data is not visualized properly, it is just the data which do not have any meaning. So the spatial data need some kind of spatial data analytics tool, and possibly those things are coming from computer science only. Okay, also if you take the manipulation or the query processing or some prediction, so we are extensively using some algorithms. Okay, and those are intelligent algorithms. You may use some machine learning algorithms or deep learning algorithms to extract the hidden patterns out of it. Okay, because we know that one single pixel in the satellite image is spanning across a huge or the big spatial space. Okay, so now in that way we are trying to use such kind of intelligent algorithms, and if you see, the base is coming from computer science. That's why one need to understand all this technology, and that is how it is related to computer science. So not only electronics engineer or environmental engineers, computer engineers or computer science people are playing very important role, right from the processing till the prediction.
Yes.
Yeah.
Beyond the visible next generation technologies, what changes come with handling large scale geospatial data?
Yeah, so this is one of the question, or this is one of the thing which everybody who is working in this field need to understand. So if you consider a very small, or if you consider a satellite image, okay, and normally we are using the normal images. Maybe I have 256 by 256 image. So we know that it is taking some amount of storage,
Yes.
maybe 2 MB. But if I am having say 1024 by 1024 image,
Yes.
with multiple bands, so I told you we have multispectral image, we have hyperspectral image, and so on, where we are having thousands of bands. So if I take one image with such several bands, the amount of storage which we need is much more higher than the normal natural images. Okay, so that itself is creating the complexity. When I say processing the satellite images and storing it in the database, it is a laborious task. It requires lot many things. It requires some field survey also, some data has to be taken, projection need to be done. Okay, and possibly now we are keeping everything on the server. So earlier, if you see, the satellite data was so expensive. It is not so easy for anybody to get the satellite data. You need to pay in crores, you need to pay in lakhs to get that data. Now if you say in today's time, the data set is easily available, and that is available in some public repositories, but we need to understand how these things get possible. So if you see, nowadays we are having the technology. Okay, we are having lot many algorithms in big data analytics, okay, which can easily process such a voluminous data. Okay, and it is being processed within a fraction of seconds. Okay, we have large we have large cloud infrastructure setup. okay, wherein we don't need to have such kind of storage space at our own server. Okay, easily we can cope up and we can use the cloud storage wherein such a huge data can be stored. Also, as I said, the technology is evolving. We have machine learning algorithms, we have deep learning algorithms, and recently we are having LLMs. Okay, so we are coming up with the multi-model LLMs, which are taking the which are trying to process the geospatial data, because the multimodal LLM is helping us to understand the textual data, the imagery which is coming in a diverse field, and not only the spatial and spectral data but temporal data also. So even though we are having such kind of complexities, as we are having technology with us and we are having this things, big data analytics, cloud computing, gen AI, okay, and deep learning and all, it becomes easy to understand that complex data, to retrieve the hidden patterns from that complex data and use it for the applications like environmental monitoring, climate change, and disaster monitoring and recovery. So that's why one need to understand the complexity, and based on that the algorithm need to be devised. And believe me, there are so many web servers available nowadays, or web applications available nowadays, who are helping you to do those things. Yeah, so that is my answer.
What advice will you give to the engineering students who are interested in building career in GIS, remote sensing, and Earth observation?
Yeah. Before putting my advice, okay, for the students, let's understand how this GIS remote sensing, okay, and Earth observation is coming together. So, as I mentioned, Earth observation is helping us, remote sensing is helping us to do the Earth observation, and GIS is on the top of that, which is trying to integrate those data, store that data, and analyze and visualize that data. So by seeing the functionality of these three different fields all together, okay, if the student want to pursue the career in this, definitely they should know the functionality of the satellite, the sensors working, okay, and obviously as they are going towards the storage of the data, processing of the data, and analysis of the data. So one need to understand how those things are working. And if you see in today's era, there are lot many machine learning and deep learning intelligent algorithms are available through which the analysis can be done. So here my advice to students who want to pursue the career in GIS, remote sensing, and Earth observation is, try to go beyond your curriculum. You may be from electronics, from computer science, or maybe information technology, or even mechanical or chemical. Okay, so every other branch can contribute in GIS, remote sensing, and Earth observation, but just try to understand that how these technologies are working. Okay, and there are lot many career opportunities. So if you are an electronics engineer and you want to pursue a career in GIS and remote sensing, probably you can take a post graduation course in remote sensing, or maybe you can take a post graduation course in geoinformatics, and that will help you to understand the technology. Okay, because the base of all this technology is engineering. Okay, so that's what the fundamental knowledge is very important, and later on they can do some specialization, and that will help them to understand this technology in the better way, and that is how they can pursue. Now if you take from the job perspective, okay, there are plenty of the job opportunities available nowadays in remote sensing. Okay, so as we have seen, we are having now a tremendous processing power. Okay, if you see now we are using LLMs and all. Okay, so they are using lots of processing power, and we are having the huge development in that. We have supercomputers, we have GPUs which can process those things. So it is not so difficult to work on that, and that is how the job in the job market also, there are plenty of the opportunities, plenty of the big companies are now shifting their focus to provide the smart city solution. Okay, if you take an example of the unmanned vehicles, okay,
Yes.
or now we have have a Tesla car. So they are using this kind of GIS remote sensing and earth observation as a core part of their
Yes.
technology. So there is a huge demand of such kind of manpower in this particular industry. So obviously, one advice I can give that students should not focus only on the curriculum. They should go beyond curriculum and try to understand this technology, and further they can pursue some specialization so that they can avail plenty of the opportunities which are available now in the research field as well as in the what you can say business field. Yeah.
These are extremely valuable and practical insights for students at all stages. Before we conclude, we would like to end with a quick round of reflection. I will ask you a few short questions, and you can answer in one word or short answer. So,
You
one
can.
skill every future Earth observation professional must develop.
Okay. So one field which is very essential is the analytical capability. So that should be there to pursue the understanding and the application perspective of the earth observation.
Okay. One technology student should focus on in the upcoming year.
Okay.
One technology
Okay,
student
okay.
should focus on in an upcoming year.
Yeah, so if you see now, I would like to take a little more time on this, even though it's a quick round.
Yeah.
So if you see in today's era, the trending upcoming technology or current technology is artificial intelligence,
Artificial.
and it is not only being used today, but in future also it is being used.
Yes.
So specifically in GIS and remote sensing, okay, this technology is playing very important role because we have this data is huge data. Okay, it's a voluminous data, and if you use a simple technology, possibly it takes years to process the
Yes.
data. So if we use such kind of technology, which is integration of artificial intelligence, big data, and cloud. Okay, so eventually this will help to get more insights on the GIS and remote sensing. So I suggest that students should go with artificial intelligence and
Yes.
big data analytics for that.
Okay. One mistake students should avoid during college.
Okay, so here possibly I would say a student should not merely concentrate on studying the stereotype in the stereotype way and just getting the bookish knowledge. They need to see how those things are applicable. So skill development is very important. So they should not do the mistake just by just learning the
Yes.
books and getting the grades. So they should see that how it is getting used by the society, and every other courses which they are learning, they need to develop some kind of mini projects or some capstone projects, and using that possibly
Yes, being
they
practical is more
can
important.
get the better insights about those things. Yeah.
What does success in academics means to you today?
Okay, so very good question, and possibly see everybody is having a different definition of success.
Yes.
Okay, but in academics, being a leader or maybe being a teacher, okay, for me, success is creating impact on students. Okay, so if you can provide a mentorship and you can create a long lasting impact on students, so that will help them in their complete future career. So for me, success is creating an impact in the academics. Of course, in businesses and all,
Yes.
success is different, but possibly in academics, teachers are the ideal face or ideal thing for students. So if you could able to create an impact among student community, that is the success according to me.
Thank you so much, ma'am, for those thoughtful and concise response. With that, we come to an end of today's podcast. Thank you so much, Dr. Chaudhary, for sharing us your insights and experience. This conversation truly helps us look beyond the visible and understand how Earth observation is shaping this future. To our listeners, the future of engineering lies in interdisciplinary thinking and real world impacts. Field like Earth observations are not just about technology but about understanding and protecting our planet. This brings us to our end of this episode of the IEEE SSGST podcast. Stay tuned for more conversations that inspire learning, innovation, and leadership. Thank you for listening.